Hello my dear students, in this video class we will talk about one more important concept of structure of atom chapter, and the topic is De-Broglie wavelength. De-Broglie wavelength is also known as dual nature concept. What is the meaning of dual nature and what is the stance here? De-Broglie. De-Broglie is the name of scientist, and wavelength means it is the distance between two adjacent crest or two adjacent trough. Means when we design wave and it is like in this motion, correct na, something like this. So the upper portion is known as crest and lower portion is known as trough. So when we will see the nearest distance between two crest or two trough is known as wavelength, correct? So it is about De-Broglie wavelength. And what is the meaning of dual nature concept? Dual nature concept means any moving object, it can be electron, it can be proton, it can be neutron or alpha particle, act as particle or act as wave. Means any moving particle can act as particle or can act as wave as per the requirement. So suppose the moving particle or moving object is electron, and suppose it's acting as particle, then its energy will be E equal to mc square, and suppose it's acting as a wave, then its energy will be E equal to h nu, and nu equal to what? C upon lambda. So that's why I put E equal to hc by lambda. So for dual character means here it's are acting as particle as well as wave. So its value will be mc square equal to hc by lambda, and further square or c will be cancelled. So hence answer is mc equal to h by lambda or lambda equal to h upon mc. Or here c can be written as v, because c is speed of light and v is velocity of light, and both have the same value. It is 3 into 10 to the power 8 meter per second, correct? H equal to Planck's constant and m equal to mass in kilogram. Always students, we will take mass in kilogram, correct now? Our value of h is how much? 6.6 10 to the power minus 34 joule second. And lambda is what? Lambda is De-Broglie wavelength. So I will remember lambda equal to h upon mv. That's it. My duty is over for the concept of De-Broglie wavelength. Now it's a simple problem. How I can attempt the numerical approach for De-Broglie wavelength? See here, one question is there. Find the wavelength of 100 gram particle moving with the velocity 100 meter per second, correct? So he is asking about wavelength, means De-Broglie wavelength, because velocity is involved. So I will calculate De-Broglie wavelength. Lambda equal to h upon mv. H is how much? 6.6 10 to the power minus 34 joule second. And you are seeing that here no joule, so I can convert joule into kilogram meter square upon second square. It is also known as equal to joule, and joule second, correct? Next, for mass I have to convert this gram into kilogram, so I converted this 100 gram into 100 into 10 to the power minus 3 kilogram, because I have to put this value in kilogram. Mass must be in kilogram. And then further v equal to velocity is and it is 100 meter per second. When I will put all these value in the equation, see, h equal to 6.6 into 10 to the power minus 34 kilogram meter square upon second square into second. Here it is mass 100 into 10 to the power minus 3 kilogram, and next is 100 meter per second. So you can cancel all the term, kilogram to kilogram, meter square to meter, and this all second term will be cancelled. So I have only meter, correct now? So I can write 100 here, see, 6.6 into 10 to the power minus 34. When this 100 will move upside, it will become 10 to the power minus 2. when 10 to the power minus 3 will move upside, it will become 10 to the power 3, and same thing with this 100, correct? So when I will solve, I will get my answer in meter, and answer is 6.6 10 to the power minus 35, and it is what? It is De-Broglie wavelength. It is value of lambda, or we can say it is De-Broglie wavelength value, correct now? So one more concept that I can design with the help of De-Broglie wavelength, it is kinetic energy. And we know, students, kinetic energy equal to half mv square, correct? So when with the help of De-Broglie wavelength, how I can change this equation? So when I will multiply m to the both side, it will become mke, see here, and half m square v square, correct? Next, m square v square, I can collectively write mv whole square, and when I will multiply 2 here, it will be 2 mke equal to mv whole square, or it can be converted into root, so it will become under root 2 mkv equal to mv, or students, here I took mv as h upon lambda. How it can be possible? See here, I can write from this mv equal to h upon lambda. Yes or no? Answer is yes. So same thing I did here. Mv equal to h upon lambda, or lambda equal to h upon under root 2 mke. What is this? This is direct formula to calculate lambda from kinetic energy. Means suppose in the equation when kinetic energy is involved and he is asking about De-Broglie wavelength or wavelength, so I can deal that question with the help of this equipment, this formula directly, correct? See one question that belongs to NCERT ping problem, and in NCERT it is huge, huge steps are involved, and I can't understand directly, so that I will use this formula, and with the help of this formula I can manage this question without any more further implementation, correct? So lambda equal to h upon under root 2 mke. I will use this formula, and the question is the mass of an electron is how much? It is 9.1 10 to the power minus 31 kilogram, okay? And if the kinetic energy is how much? See here, 3 into 10 to the power minus 25 joule. I have to calculate its wavelength. So when I will put the value of h, it is fixed always. It is Planck's constant, and it is answer 6.6 10 to the power minus 34, correct? 2 is 2. Mass I will put 9.1 10 to the power minus 31 as per availability in the question, and the kinetic energy is 3 into 10 to the power minus 25, correct? When I will solve this, minus 31 minus 25, it will become 56, and 2 9.13, it will around 54.6. So how I can solve? Because 56 will become half of the this power when root will be removed. It is 28, and when it will move upside, it will become plus 28. Means there is no issue. But how I can solve 54.6? See here, 49 is the root of 7. Yes or no? Answer is yes. And 64 is the root of 8. Correct? 64 is the, we can say, when I will solve under root 64, I will get 8, and under root 49, I will get 7. Correct? So 49 and 64, there is one digit between them, that is 54.6. And for 54.6, I can take 7.4. It can be possible, no problem. So here root of 54.6, it is 7.4 on behalf of what? Under root of 49 and under root of 64. Directly I can design, correct now. So when I will solve, it will become minus 7 and 60, basically answer will be 6.6 10 to the power minus 6. When I will borrow 1 0, it will become 66, because it will be easy for me to solve further, and when power will be decreased, minus 7. When I will solve it, I will get 8.9 10 to the power minus 7 meter. So some trick I used to solve the problem which is based on kinetic energy, and how we can solve the root problem, correct? So directly you can take some middle values of two nearest under root, correct now? So it's all about De-Broglie wavelength. You can solve more questions in NCERT, or you can take some problem for a refresher also, correct? So I think its concept is clear, and there is there should not be more doubt, because directly I will use lambda equal to h upon mv, and for wavelength calculation I will use lambda equal to h upon mv, and suppose if kinetic energy is involved, directly I can use lambda equal to h upon under root 2 mke. Suppose sometime kinetic energy is not there, here energy is given in the form of electron volt, directly we can use under root 2 m, and in place of ke it will be electron volt. So it's further implementation, and when we will move ahead we will get more, correct? So I think it's enough to understand how we can solve the concept of De-Broglie, how we can solve the numerical based on De-Broglie, and when kinetic energy is involved, how we can manage the question, or how we can solve the question using this formula, and formula is lambda equal to h upon under root 2 mke. So students, what's your duty? Your duty is to learn this formula, D for De-Broglie wavelength, lambda equal to h upon mv, and when kinetic energy is involved, what formula I will use? Answer is lambda equal to h upon under root 2 mke. And when you will do more practice, you will more comfort with this topic. So in next day we will meet again, and we will solve some more concept and more interesting factor, interesting fact we will take. So till then, thank you very much.